The topic for this video is oxidation and reduction. The essential questions are what does The topic for this video is oxidation and reduction. The essential questions are what does reduction mean, what does oxidation mean, and what is a redox reaction, and how can you identify it? So the first thing I want you to try to remember is that Leo the lion says grr, and that's going to help you remember the difference between oxidation and reduction. So Leo the lion says grr. Leo stands for loss of electrons is oxidation. L-E-O. Loss of electrons is oxidation. Okay. For instance, when sodium gets a charge, it loses an electron, so it's been oxidized. Reduction is gain of electrons. So grr means gain of electrons is reduction. So for instance, chlorine likes to gain an electron, so the chlorine ion has been reduced. The oxidizing agent does the oxidizing, so that would be getting reduced, for instance, the chlorine. And the reducing agent does the reducing, so it gets oxidized, which would be the sodium in the example. So those are kind of flip-flopped. So if it gets reduced, it's the oxidizing agent. If it gets oxidized, it's the reducing agent. So we're going to look at how to assign oxidation numbers. A lot of this is really closely linked to the charges. A free element is always 0, and a free element is something that's not bonded. For example, hydrogen. So you just put a 0 up there, or calcium is a 0, so it's not bonded to something else. Metals have an oxidation number that is the same as their ionic charge, so that's all your positive charged ones. So for instance, sodium would be a +1, aluminum is a +3, silver is a +1, so you can always count on that as being the same as their charge. Hydrogen is always going to be +1 in compounds. And oxygen will always be -2 in compounds, and that's going to be really important when we get to the polyatomic ions. So, for example, water, hydrogen's a +1 and oxygen is a -2. Okay, the sum of the oxidation numbers must be 0 for a neutral compound. Okay, so you have Ba3N2. We can do our metal because we know that that's a +2 charge. Our nonmetals don't always end up matching with their charges. So we have to investigate. A +2, and there's 3 of them, make a +6 charge. So that's going to be the opposite. It's going to be a -3 charge because this has to be a +6 and that has to be a -6 to make 0. Okay, so we're going to practice this a little bit. KCl, we know K is a +1 and we know it has to equal 0, so Cl has to be -1, which happens to equal its charge. Okay, but if we look at the next one, it's going to be a little bit different. K is still the +1, and remember we just said oxygen is always going to be a -2. So that tells us that we have 3 oxygens, so that's a total negative charge of 6, and we only have 1 potassium, so that's a +1, okay, and it has to be 0. So because this is a polyatomic ion, the chlorine's going to have a different charge this time than what we're used to, or a different oxidation number than its charge, I'm sorry. And so it has to be a +5 because there's only 1 of them. So that's its oxidation number in this compound. So you can see in the first compound, chlorine was -1 oxidation. Now chlorine's +5. And we had to do that because they have to balance out to 0. Okay, let's look at another one. Potassium's still a +1, oxygen is still -2, but now there's only 2 oxygens, so it's a -4 charge. And potassium's a +1, we have to make it a +4 somehow, so that chlorine now is a +3 oxidation. And that equals out to 0. Okay, hydrogen we said was always a +1, and there's 6 of them, so that's a +6. So the carbon has to come up with the -6, and there's 2 of them, so each one's going to be a -3. If we look at hydrogen here, it's a +1, there's 3 of them, and there's only 1 nitrogen, and it has to be a -3. Oxygen has to be a -2, and there's 2 of them, so that makes a -4. There's only 1 nitrogen, so it has to be a +4. So the ones that we're used to thinking of as negative charges, they're going to change around depending on what needs to happen on these oxidation numbers. So then this next part asks us to identify the element that gets oxidized and the one that gets reduced, and also identify the oxidizing agent and the reducing agent. So if it's been oxidized, that's because the number went up on the charge, and if it's reduced, that's because the number went down, and we're talking about from one side of the arrow to the other. So we're going to go through and label these first. Magnesium is all by itself, so it's 0. Hydrogen in a compound is +1. Oxygen in a compound is -2. And so I have -8 and +2, so I need a +6 there for the sulfur to make it all even out. Okay, on the other side, magnesium is a +2 because that's its charge. Oxygen is -2, so that makes a -8 and a +2, so again, sulfur is a +6. And hydrogen is all by itself now, so it's 0. So if I look at these, I want to pick out the ones that changed. And if I look at magnesium, it went from 0 to +2. If I look at hydrogen, it went from +1 to 0. Sulfur didn't change, it stayed +6, and oxygen didn't change, it stayed -2. So we don't care about the sulfur and the oxygen. Okay, so if we look at magnesium again, the number went up. So magnesium was oxidized because it went from 0 to +2. And if we look at hydrogen, it went from +1 to 0. The number went down, so that means it was reduced. Now remember what we said at the beginning. If it gets oxidized, it's the reducing agent, so that's the magnesium. And if it gets reduced, it was the oxidizing agent. So let's try another one. Some of these are labeled for you. Okay, we need to label the KMnO4. So K is a +1, O is a -2. So that makes a -8 charge on the oxygens, and you have a +1, so we need that manganese to be a +7. Okay, we have a tin with a +2 charge, a hydrogen with a +1 charge. On the other side, manganese with a +2, tin with a +4. The hydrogen has a +1 and the oxygen has a -2. So we're only going to worry about something that changed. If we look at the K, it's not on the other side, so we're not going to worry about it. Okay, Mn started as +7 and ended up as +2, so that got lower. Okay, oxygen was -2 and -2, so we don't worry about that. If we look at the Sn, the tin went from +2 to +4, so it got bigger, and then the hydrogens on both sides are +1, so we're not worried about that. So the manganese got smaller, that means it was reduced, and it's the oxidizing agent. The tin got bigger, that means it was oxidized, so it was the reducing agent. Okay, let's look at another one. Hydrogen is +1. That has to mean carbon is -4. Oxygen by itself is 0. Oxygen bonded is -2, and there's 2 of them, so that makes -4, so carbon has to be a +4. Hydrogen's +1, oxygen's -2. So if we look, our hydrogens did not change. Our oxygens did, though. On the one side, they're 0. On the other side, they're -2. Our carbons also changed. They went from -4 to +4. So carbon got bigger, so that means it was oxidized, and it's the reducing agent. Oxygen got smaller, so that means it was reduced, and it's the oxidizing agent. Okay, let's look at another one. Aluminum by itself is 0. Oxygen by itself is 0. Aluminum, this is a -2, and aluminum is a +3. So aluminum got bigger, so that means it was oxidized and is the reducing agent. Oxygen got smaller, that means it was reduced and is the oxidizing agent.